Modern medicine started to emerge after the Industrial Revolution in the 18th century. As economic activity grew in Western Europe and the Americas, scientific inventions and discoveries too grew leaps and bounds. But the roots of modern medicine can be easily traced to ancient Greece, India, and China. Welcome to The Why in History. I am Ajay Kaul, and today we trace the history of modern medicine, including its roots from ancient civilizations. Though humans regarded common maladies such as colds and constipation as ailments that needed to be treated by means of herbal remedies, but various disabling diseases were placed in the category of the supernatural. And these could be the result of a spell cast upon the victim by some enemy or the visitation by a malevolent demon. And the treatment here was to extract the evil intruder by counterspells, incantations, or potions, etc. Ironically, though, the father of modern medicine comes from the ancient times, Hippocrates, after whom the Hippocratic Oath has been named. The reason Hippocrates is considered the father of modern medicine is that even though he was from the ancient times, he was the first medical person to look upon disease as a science which needed to follow the process of observation, classification, cause and effect, instead of the supernatural or religious approach. The Hippocratic Oath, though not directly attributable to Hippocrates, is an oath that the medical practitioner takes to respect their teacher and not to administer poison or abuse their patients in any way. Also, it swears not to break the confidentiality between the patient and the doctor. Contrary to popular belief, when it comes to ancient Indian medical science, it is not the concept of Ayurveda mentioned in the Atharvaveda, but the medical treatises known as the Charak Samhita and the Sushruta Samhita, produced between 800 BCE and 1000 CE, that heralded the golden age of ancient Indian medicine. Charaka, the author of the Charaka Samhita, was a physician, whereas Sushruta, the author of the Sushruta Samhita, was a surgeon. Yes, in the ancient Indian times, surgery was popular. The ancient Indian physicians employed the five senses towards the diagnosis of a disease. For example, hearing was used to distinguish the nature of the breathing. The medicines mainly consisted of vegetable drugs, all of which were from indigenous plants. Charaka knew about 500 medicinal plants, whereas Sushruta used about 760. But non-plant ingredients were also used, for example, milk from various animals, and minerals like sulfur, arsenic, lead, etc. And some of these ingredients eventually did make it to Western pharmaceuticals, notably cardamom and cinnamon. And as I mentioned earlier, when it came to surgery, the surgeons from ancient India really excelled in their craft. Operations performed by the surgeons included excision of tumors, incision and draining of abscesses, splinting of fractures, amputations, C-sections, and stitching of wounds. A broad array of surgical instruments were used, and according to Sushruta, the surgeon needed to be equipped with 20 sharp and 101 blunt instruments. The instruments were largely of steel, and alcohol was used as a narcotic during the operations, and bleeding was stopped by hot oils and tar. Specifically, there were two types of operations the ancient Indian surgeons seem to have mastered. The first was the stone in the bladder, and the surgeons frequently removed these stones by lateral lithotomy, which is essentially a procedure in which a surgical incision is made and the affected organ opened surgically to remove the stones. What is interesting about the bladder stone removal is that the Sushruta Samhita very clearly articulates how the patient is supposed to be rested prior to the operation, how the operation is supposed to be conducted, the do's and the don'ts, including the post-surgical care of the patient. The second type of operation that the ancient Indians had mastered was plastic surgery. Whoa, plastic surgery? Yeah, actually, the amputation of the nose was one of the prescribed punishments for adultery. So there was a huge market for the post-punishment repair. And this was carried out by cutting from the patient's cheek or forehead a piece of the tissue of the required size and shape and applying it to the stump of the nose. The results appear to have been tolerable, and the modern surgery is also derived somewhat from this ancient source. But transitioning to the medieval times, the quality of surgery definitely went down. Why? Because the surgeon was replaced by the barber surgeon in Europe during the Middle Ages. Barber surgeon? What's that? Well, in this era, surgery was not conducted by physicians, but instead by barbers who possessed razors and various other skills which were kind of in line with surgery. So they were called upon for numerous tasks ranging from cutting hair to pulling teeth to amputating limbs. And not to be surprised, the surgical mortality was very high during this period due to blood loss, shock, and infection. But physicians considered themselves to be above surgery, and they mostly observed during surgery and offered consulting and let the barbers perform the surgery. Overall, the 19th century is regarded as the birth of modern surgery, because it was during this time that many firsts were discovered which enabled many of the modern procedures to take effect. In 1846, the first public use of ether as anesthesia was demonstrated in a surgery performed at the Massachusetts General Hospital in Boston, involving the removal of a neck tumor. In 1867, British surgeon Joseph Lister published an article in the British Medical Journal extolling the virtues of cleanliness in surgery, where he discussed carbolic acid as one of the first agents to be used to disinfect surgical incisions and prevent post-operative infections. In 1896, the first successful open-heart surgery was performed in Germany to repair a stab wound in the muscle of the heart. So all these firsts cumulatively combined, and by 1900s, the likelihood of surviving surgery was greater than the likelihood of dying during or as a result of surgery. Another ancient civilization which made good strides in medical science was China. Huangdi, one of the legendary founders of Chinese civilization, wrote the Canon of Internal Medicine, or the Huangdi Niezheng, in the 3rd millennium BCE. It considered the human body like matter, which is made up of 5 elements: wood, fire, earth, metal, and water. The ancient Chinese conducted a fairly detailed diagnosis of an ailment, asking about the patient's taste, smell, and dreams. Conclusions were drawn based on the quality of the voice, the color of the face, and the tongue. However, the most important part of the investigation was the examination of the pulse. The pulse was examined in several places and at different times and with varying degrees of pressure. And it was used for both diagnosis and prognosis. That is, the cause of the ailment as well as the possibility of recovery. Just like ancient India, ancient Chinese medicines also consisted of vegetable, animal, and mineral remedies. And several of these remedies were later acquired by Western medicine as well. And some of these included castor oil, camphor, Indian hemp, and rhubarb. Chalmugra oil was used by the Chinese for leprosy, and by the 19th century began to be used for the same purpose by Western physicians as well. And the most popular herb among them, ginseng, was adopted by Western physicians, though it has lesser curative qualities and more betterment qualities like enhancing mental performance, learning, and memory and sensory awareness. One of the earliest inventions with respect to medical science by the Chinese was the practice of inoculation. Yes, inoculation of smallpox in order to produce a mild but immunizing attack of the disease was practiced in China in ancient times and came to Europe only in about 1720. The knowledge about smallpox vaccination came to Europe from Turkey in 1721, and it was only in May of 1796 that English physician Edward Jenner put to rest all the speculation around the smallpox vaccine by inoculating an 8-year-old patient with matter collected from a cowpox sore on the hand of a milkmaid. The patient was unwell for several days, but later made a full recovery. The term vaccine was later coined, taken from the Latin word for cow, that is, vacca. The next major milestone in the history of vaccination was in 1885 when Louis Pasteur successfully prevented rabies through post-exposure vaccination. Louis Pasteur was not a doctor, but a chemist and a microbiologist, and his rabies vaccine was a course of 13 injections, each containing a stronger dose of the virus. Louis Pasteur's patient survived and later became the caretaker of his tomb in Paris. The big event in the early 1900s was the Spanish flu pandemic, which killed approximately between 20 to 50 million people worldwide. The pandemic spread between 1918 and 1919, and it became a priority for the US military to find a vaccine for the flu. But it was only in 1933 that British researchers Wilson Smith, C.H. Andrews, and P.P. Laidlaw at London's National Institute for Medical Research found that the flu was caused not by bacteria, but by a virus. Subsequently, Thomas Francis and Jonas Salk at the University of Michigan developed the first flu vaccine, which was tested for safety and efficacy on the US military before being licensed for wider use in 1945. From 1952 to 1955, the first effective polio vaccine was developed by Jonas Salk and tested on himself and his family the following year. Mass trials for the vaccine took place in 1954, involving over 1.3 million children. Looking at the Arabian region, the greatest contribution of Arabian medicine was in chemistry. In other words, the knowledge and preparation of medicines. Though the chemists at that time were mainly alchemists who were looking for the philosopher's stone, which would turn common metals into gold, but in the course of their experiments, many new substances were discovered, and some of them were found to have medicinal value. One of the most impactful inventions of the 18th century was the stethoscope, invented by René Laennec to decipher the sounds in the heart and lungs that would lead to diagnosis of an ailment. And René Laennec invented the stethoscope out of pure necessity. He had a female patient who was suffering from shortness of breath, and René was too embarrassed to place his ear on her chest. So what he did He rolled up 24 sheets of paper, placed one end to his ear and the other on the woman's chest, and he was delighted to discover that the sounds were conveyed loud and clear through the paper cone. So he went home and created the stethoscope from a turned piece of wood with a hollow bore in the center. One end had a hole to place against the ear, and the other end was hollowed out into a funnel-shaped cone to listen to the heart and the lungs. The stethoscope was 12 inches long and 1.5 inches in diameter and looked nothing like the ones we see today. Between the 19th and the 20th centuries, Western medicine finally came of age based on scientific research into the underlying cause rather than just treating the symptom. As the Industrial Revolution spread and led to urbanization in the 19th century, waterborne diseases of dysentery and cholera became more common. It was only in the latter half of the 19th century that French chemist and microbiologist Louis Pasteur revealed that invisible microorganisms were the cause of spoilage, and that led to the germ theory of disease. Subsequently, German physician and microbiologist Robert Koch discovered 3 different strains of bacteria, and all 3 of these were important pathogens of major infectious diseases. Now, the challenge was how to fight the bacteria. And in 1928, Alexander Fleming discovered penicillin. And as it was mass-produced, it opened the door for the golden age of antibiotics, which could counter any bacterial diseases or infections. One key factor in the 20th century that helped overcome infectious disease was the communication between scientists across the globe. Through publications and conferences, and later electronic media, scientists were able to freely exchange ideas and report on their discoveries. The first half of the 20th century was focused on combating infection, notably bacterial infection. Bacterial because it was not until the 1930s that scientists began to understand viruses. And the 2 developments that contributed to the growth in knowledge about viruses were the introduction of tissue culture, which means the ability to grow viruses in the laboratory, and second, the availability of the electron microscope. Once the virus could be cultivated with comparative ease in the laboratory, it gave the ability to the researcher to study and carefully evolve methods for producing one of the 2 requirements for a safe and effective vaccine. One, either the virus was so weakened that it could not produce the disease for which it was responsible in its original form, or 2, a killed virus that retained the faculty of inducing a protective antibody response in the vaccinated individual. And as a result of these developments, the first vaccine for combating a virus was the one developed for yellow fever by microbiologist Max Thiele in the late 1930s. And these led towards bringing under control 3 major diseases of that time: yellow fever, polio, and influenza. Another major development in the 20th century was in the field of nutrition, with the discovery and appreciation of vitamins. And once the concept of vitamins was established on a firm scientific basis, their importance in supplementing natural food towards maintenance of health also became very obvious. Specifically, by supplementing the diet with foods containing particular vitamins, deficiency diseases such as rickets due to vitamin D deficiency and scurvy due to vitamin C deficiency practically disappeared from Western countries. And on the same note, diseases such as beriberi, caused by a lack of vitamin B, which were endemic in Eastern countries, gradually disappeared as well. And on that nutritious note, we end this section of the program. On to the quiz section. Question from the previous episode. Which son of a brutal dictator made a documentary about his father? Vittorio Mussolini, a filmmaker and the second child of fascist dictator Benito Mussolini, made a documentary about his father in 1983. So the answer is B, Vittorio Mussolini. Question for the current episode. Why is Sir William Osler considered the father of modern medicine? Is it A, he was the first to understand viruses? B, his innovative surgical techniques? C, his innovative medical teaching curriculum? Or D, for pioneering organ transplants? Once again, why is Sir William Osler considered the father of modern medicine? Is it A, he was the first to understand viruses? B, his innovative surgical techniques? C, his innovative medical teaching curriculum? Or D, for being a pioneer in organ transplants? The answer will be provided in the next episode. That's all we have in the current episode. As several countries across the globe conduct elections for their respective governments, we'll take a look at some historic elections which led to either an upset of a favorite candidate or a surprising victory of an underdog. It will be an exciting episode, so do tune in. But till then, stay safe and keep exploring the why in history.